What we got here is a Toyota 7HBW23 small walkie. Complaint from the customer is that it's coding out C14 right off the bat. So let's punch it in. Code. Okay, that's active. And C14 right away. Let's look at it again. So off. And then I'm going to punch in the code. Okay, it's up C14 right away. Okay, so that's the code that we're getting. 24.36 on the battery. So C14, if you look at the book, is saying that one of these switches here, which is the arm angle, is already giving out a signal to the computer when the handle or the tiller arm is still up. So next thing we're going to do is we're going to take this off and check the individual switches.
So before we go on and check that switch, I just want to look at the code C14 again, basing from the book. And we have here the C14, and of course I've seen this before. It's an arm angle reference warning. Okay, control handle was not up in the position at power on or after the truck has not been used for a while. Of course, it would only limit the travel and not the lift. And how to clear the code: tiller arm is moved to the upright top brake position. That is only when everything is working fine and the switch are working. So possible causes would be control handle stuck up in the down position, right? Arm angle input stuck on, and it tells us to check the arm angle switch A and B for correct operation. Repair or replace as necessary. And then the next one, or the last one, would be check input to power amplifier. Right, so let's get back to it.
Okay, so I took up the switches just to make it easier to test. When the tiller handle is up, both switches should be disengaged. No continuity whatsoever should be on no switch. Right now, this is the switch that is of concern to me. So if I test it on this one, you can see that's almost battery voltage. This is the source, but if you look on the other side, right now it should be 0, but it's reading 22.85. Now I already tested the other switch, and that one is working as it should. 0 on the signal wire when the switch is not activated, and then it only gets voltage when the switch is pressed. But on this one, as you can see, 22.85. This is the source, almost close. And then going back here, 22.85. If I press the switch, and it reads the same voltage on the other side. Alright, so it might be the switch. So what I'm gonna try to do is disconnect this guy, alright, and check on this terminal. Okay, checking on that terminal right now. Okay, I'm still reading the 22.85. Alright, so right here, nothing, 0. And if I press that, that's the only time that it should have voltage. So press it. Okay, that's working as it should. So the switch is not shorted. So the question now is, why am I getting the voltage on this wire? So only two possibilities left. One is going to be a short in the wire, that somehow one of these wires, which is supposed to have a positive, is touching this, which is possible. And I've seen it happen before, that it's rubbing against here on the inside. But it could also be possible that it is an internal short here. So what I'm going to do right now is to prove that if it's going to be a short in the wiring, or a short in the controller, is I'm going to have to pull this wire, which is the same wire that goes to this switch right here, which is 50. So 50.1, and this is also 50.1. Okay, we're gonna have to do that next.
Okay, so right before we get down to checking out the wiring, I pulled out the schematic for it, So these are the switches that we are concerned about. And of course, we know that we're not concerned with both. We're just concerned with one. And we know that when the switches are open, you have a common here which goes from the master control switch, and you are supposed to be supplied by 24 volts. So 24 volts is here, or at least close to it, battery voltage. And when the tiller arm is moved downward, it will activate the switches, and you would get 24 volts into the Curtis controller in these two pins, 50 and 51. So we are only concerned about this one, but my concern also is you have the whole harness, and one of these wires possibly, right, which goes into the pump contactor, the brakes, or whatever, could be touching the wiring harness, or the signal wire that goes into the Curtis controller. So what we have to do is isolate this wire. And why do we want to isolate it? So if I unplug this wire from the Curtis controller, the reasoning is I know my switch is good. If I isolate this wire out of the controller and I still see the 24 volts or close to 24 volts, then the conclusion is that 24 or 22, whatever the voltage is that we're reading, is not from the computer or is not from the Curtis controller, but it's going to be a short in the harness. Somehow one of these wires is touching that signal wire. But if the 22 volts or whatever is gone after I isolate this or take it out of the controller, then the only possibility is that voltage that we're seeing is coming inside this controller. Right? Hope that makes sense. So let's get back to it again and see what we have.
Alright, so took out the wire from the Molex connector by using one of those the pinning tools. So I've already isolated that wire, so I don't need to be keyed on right now. I just need power because the voltage or the power for the switch comes from the battery through a fuse and straight out. It doesn't require for me to use the keypad to get power to that. So right now my wire is right here connected again, and this is going to be the other end that's supposed to go to the computer. If I press it, okay, I see the voltage there. So meaning to say that for me is saying that my wiring is good. It's only getting power when the switch is activated at this point. So why were we seeing 22.8 something earlier? Then the conclusion is that 22 volts is coming from inside the computer. Alright, so it gives me more confidence now to say that there is something wrong with the computer. My next test would be to replace the computer to verify the findings. Alright, so put another controller in, put all the wiring back, plug that in, key on. This one, let's look at it. Okay, no codes. Okay, let's try to drive. All good. Alright, no code, 70%. Up, down. Alright.